All right, guys, let's get started. So 8F.2 today. That sound about right? Good. That's the one we're up to. So we're just proceeding from z-scores and quantiles, and we're looking at using them to find an unknown mean and standard deviation. Okay, so what we have here, we have the weight of snapper has a standard deviation of 700 grams. Given 20% of the population weigh more than 3,900 grams, find the mean of the population. So let's sketch what we know here. All right, so we've got, it has a mean of, we're not sure, but a standard deviation of 700. And then we're told 20% weigh more than 3,900. So whatever this is, that has an area of 0.2. All right, so what we're going to do here is we're going to convert this distribution to a z-score. We're saying, what is this result as a z-score? Because if you think of the z-distribution, right, the z-distribution has a mean of 0 and a standard deviation of 1. And if I can figure out what that z-score is, then I can easily figure out the unknown mean and standard deviation. So, to find the z-score, we're doing an inverse normal calculation. We want this value of k such that the area is 0.2. Alright, so remember a z-score is a measure of how many standard deviations a value lies from the mean. So we want to know what's the z-score of that value. So here's the z-distribution, and so we're going to do an inverse normal calculation. So we're statistics, normal distribution, inverse normal. Our tail is pointing to the right. Our area is 0.2. Our mean is, our standard deviation goes first, standard deviation of 1 and a mean of 0. And the reason that's the case is because we're talking about the z-distribution, right? So has anyone got it before me?
0.84.
So we've got k is 0.84. Alright, so this has a z-score of 0.84. Alright, now remember, the formula for a z-score is x take mu divided by sigma. Okay, x take mu divided by sigma. Now, our z-score for this result is 0.84. Alright, is 0.84. The result corresponds with a weight of 3,900. We don't know the mean, but we do know the standard deviation is 7. And now it's a linear equation. Okay, now we can see the link between the two distributions. We can see why we did that. We're trying to get the mean by itself. So how are we going to do that? We'll multiply both sides by 700. And then I'm going to move the mean over this side and that number over that side. So I'll just perform a first 0.84 times 700. We've got 588. $3,312 grams. Okay, so let's break down what did we do there. These distributions help me to think about it. So I'm asked to find the mean. I don't know what the mean is of the distribution, but I do know that 20% are larger than 3,900. So I go, what is the z-score of that result? So I did my z-distribution, and I'm saying, what's the z-score that corresponds with that? It's 0.84 from the inverse normal calculation. Here's my formula for a z-score. I sub in what I know, and then I just process for the mean. All right, really good. So let's move on to the second question then. And I'm going to just spin the board around. Okay, so in the second question, we've got the percentage results for a physics class are, we've got the physics test is normally distributed with a mean of 70, standard deviation of 10.5. I'm going to write it up here. Mean of 70, standard deviation 10.5. And for the chemistry class, it's a mean of 73 and a standard deviation of 12. Okay, Lucy got 83% in physics and 85% in chemistry. What subject did she do better in compared to her peers? So here we're just going to calculate the z-score that she got for physics and the z-score that she got for chemistry. So in physics, she got a result of 83. So 83, take the mean, divided by the standard deviation. And we'll do the same for chemistry. We've got 85% in chemistry, take the mean, divided by the standard deviation. So what's that, 13 on 10.5 for the first one. So she's 1.23 standard deviations above, 238, 1.24. And for chemistry, what's that, 12 on 12, 1. So she did relatively better in physics, right? Her result is higher above the mean, so her physics result is better. Which subject did she do better in compared to her peers? Physics. So that's part A. All right, let's move on to part B. A maths teacher isn't prepared to publicly release the mean and standard deviation, but he does tell her 6% of the class scored better than her result of 87%, and 13% of the class failed, that is, received a result less than 50%. So I'm not announcing the mean, not announcing the standard deviation, but we can calculate it based off this information. So let's sketch the distribution for the math test, okay? We know 6% of the class received a result larger than 87%. So let's say that's 87%, okay? And only 6%, this has an area of 0.06. Okay, that's one of the things we know. And we also know that 13% of the class, so that area is a bit bigger, that's 0.13, received a result less than 50%. Okay, so somewhere along here is this distribution has some mean and some standard deviation. We don't know what they are. So let's think, how did we do it with the previous question? We said, what is the z-score of these results? So we draw our z distribution for these, right? Here's the mean, here's the standard deviation, and we're saying, what's the z-score such that the area, we'll call it K1, is 0.06. And what's the area, what's the z-score, we'll call it K2, such that the area is 0.13. So we're getting two z results there that are going to correspond with this point. K2 corresponds with this one. And I'm going to call them z1 and z2 actually, because we'll have the formula for a z-score in a moment. z1 and z2. So for the first one, to get z1, we're doing an inverse normal calculation. Okay, we have a tail pointing to the right. We have an area of 0.06. For a z distribution, the mean is, standard deviation comes first, sorry. Standard deviation 1, mean of 0. And we'll put that in to get our value of z1. Stack, distribution, normal, inverse normal, tail right, 0.06. 1.554. Okay, so this z-score is 1.55 standard deviations above the mean. So I'm going to change it from z1 to 1.55, and we'll go for z2 next. So in order to calculate z2, my tail is going to be left, because it's the left of the distribution, and my area 0.13. Everything else remains the same. 0.13, tail left, minus 1.126, 1.13. So we've got Z1 and we've got Z2. Very good. Okay. Now, the formula for a Z-score, I'm going to clear up this left-hand space because we've got a bit of algebra to do here. The formula for a Z-score is X take mu divided by sigma. So for Z1, all right, Z1 has a result of 87%. So Z1, now the Z-score for 1 is 1.55. 1.55 equals 87%. Take the mean divided by the standard deviation. We don't know what the mean is, we don't know what the standard deviation is. That's our first equation. All right. Let's just manipulate it a little bit. All right, so one thing I'm going to do is multiply both sides by sigma first. So we'll have 1.55 sigma equals 87, take the mean. And then I'm going to plus the mean to both sides. I'm going to have the variables on one side and the numbers on the other side. So we'll have 1.55 sigma plus the mean equals 87. Okay? Same equation, we've just rearranged it a little bit. All right, so that's what we got from Z1. Okay? Next, let's use Z2 and see what can we get from Z2. So we'll put a little 1 there to describe that's equation 1. Okay, for Z2, we had a Z-score of minus 1.13, and it corresponded with a result of 50%. So Z equals the result, take the mean divided by the standard deviation, and similarly, we're going to rearrange this one to get the variables on one side. So we'll have minus 1.13 sigma. So first multiply both sides by sigma, and then add the mean to both sides. This is equation 2. So whenever we have two unknowns, right, we've got sigma is an unknown and the mean is an unknown. We don't know what they are. We've formed here a set of simultaneous equations. All right? And there's basically 3 ways we can solve a simultaneous equation. We can perform substitution, we can perform elimination, or we can use our calculator. So I'm going to do, I might do 2 of those up here. I think when this question pops up in a test, you don't need to do the, you don't need to do it manually, all right? That's sort of the skill we learn in Year 10. We're more interested in can you find the answer rather than what's the way that you do it. So let's do substitution. I think is the best one because it doesn't matter the form that the equation is presented in. It's sort of one that's more common. So let's write our equations up here. We have minus 1.13 sigma plus the mean equals 50. Okay, that's my second equation, and my first equation was 1.55 sigma plus the mean equals 87. They're the 2 equations that we're wrestling with, right? So what we're going to do is I'm going to move. I'm just trying to think what's going to be the easy way to do it. Doesn't really matter. I'm going to move. Yeah, I'm going to move this over to that side. So we've got the mean equals 87, take 1.55 sigma. Okay, I've got that from this equation. That's from equation 2. And now I'm going to substitute it. I'm going to take that and put it into equation 1. And what we've done there when we perform substitution is we've gotten rid of one of the variables. We've reduced it from 2 variables to 1. Now there's only 1 variable to solve. So I've taken that equation there, I've rearranged it to get the mean by itself, and I'm taking that mean and plugging it in here. So that's going to leave us with 1.13 sigma plus 87 take 1.55 sigma equals 50. All right, so that's just the substitution. See how I had the mean there, but I've replaced it with what I rearranged for it here. Then we'll collect those. So minus 1.13 take 1.55, that's going to be minus 2.68. sigma plus 87 equals 50, and then we're just solving this linear equation. .8. Okay, standard deviation is 13.8. To find the mean, we're going to take that 13.8 and plug it in here. The mean is 87, take 1.55 times the standard deviation. And just process that one. Oop, 113.8. 65.61. Okay, so we found the mean and we found the standard deviation. Now, I don't want us to get bogged down in the substitution. It's sort of a skill that is assumed knowledge. But let's talk about how we can use our calculator. What we'll do for our calculator is we're going to come back to this step up here, and we're going to go into equation solver. So we'll go menu, equation solver, simultaneous. It's a simultaneous equation because we have two equations with two unknowns. So we press that there's two unknowns. And then the way that you enter this into your calculator is you just put the coefficients. So in our calculator, we're going to have minus 1.13, we're going to have 1, and we're going to have 50. And then we'll have 1.55, 1, and 87. We type that into our calculator, press execute, and it's going to come up with these as our solutions. Okay? So definitely using the calculator is easier. Feel free to do it. But substitution is useful because every now and then you have a linear equation that doesn't substitute, that you can't put the syntax straight into this. It does require the substitution there. Okay, so what have we done today? Hopefully this skill is just a revision. The new skill, the really new skill is going, how can we use a z distribution to correspond with a distribution that we don't know the mean and standard deviation for? So it's just 8F.2. Again, I think it's quite a short exercise. That's what we're dedicating the lesson to today.